Hello everyone, welcome to the next tutorial. In this tutorial, we are going to learn about capacitor. Okay, so what is capacitor? So capacitor is basically a two-terminal device, okay, two-terminal passive device that is used to store energy in form of your electric field. Okay, so it consists of two conducting plates, okay, two conducting plates which is separated by a dielectric. So this is your dielectric or you can say in an insulating medium. Okay, so let's say it is a capacitor and it is connected across a DC supply. Okay, let's say the charge accumulated on this side of the plate is your positive and this is your negative. Okay, so the total charge that will be accumulated on the capacitor Q will be directly proportional to the voltage across it. Okay, so Q will be directly proportional to the V. Okay, so if we remove the constant of proportionality over here, we are getting Q is equal to CV. Okay, so Q is basically your charge, okay, and V is the voltage. Okay, and C stands for your capacitance. So capacitance C will be equal to Q upon V. So it means that like the capacitance of a capacitor is measured in coulombs per volt, or you can say farads. Okay, farads. Again, Q is equal to CV. Okay, so if we differentiate charge with respect to time, we are getting dq by dt will be equal to C d on dt of your V. Okay, so this change in charge with respect to time is your current I. So I will be equal to C d over dt of V. Okay, so this is a very important expression and you need to remember it. Okay, this is also known as your seventh form of Ohm's law. Okay, seventh form of Ohm's law. So it means that the voltage V will be equal to 1 upon C in a given time interval t, I into dt. Okay, so this is your eighth form of Ohm's law. Okay, so we can also calculate the value of the energy that has been stored in a capacitor. So we know that P is equal to V into I. On substituting the value of the current, we are getting V into C d by dt of your V. Okay, also the work done or the energy is given as integration of P into dt. It means that on substituting the value of P over here, we are getting integration of C V dV. Okay, so which will be equal to C V square by 2. It means that the energy stored, okay, so the energy stored will be equal to 1 upon 2 CV square. Okay, also Q is equal to CV. It means that C will be equal to Q upon V. So on substituting the value of the capacitance over here, we can say that it will be equal to 1 upon 2, okay, QV, or you can say it can also be equal to Q square upon 2C. Okay, so I hope it is clear. So some important points which you need to remember. Important points. Okay, so number one. Okay, so number one. So the power dissipation. So power dissipation in case of a ideal capacitor. So in case of a ideal capacitor is your 0. The reason for that is because in case of a ideal capacitor, there will be a ideal dielectric. Okay, dielectric. So it means that the leakage resistance will be equal to 0. It means that the I square R loss will be, or the heat losses will be 0. So the power dissipation or the power loss in case of an ideal capacitor is always 0. Okay, the next point we have is capacitor stores energy. So capacitor stores energy in form of electric field. Since capacitor is storing energy, So it means that it is basically a dynamic element, okay? Dynamic element. So practically a capacitor can be represented as a with a series resistance, okay? So with a series resistance connected to it and your leakage resistance in parallel. So it is basically the leakage resistance, and this is the series resistance, and this is the capacitance of a capacitor, okay? So RL, this particular resistance is responsible for your dielectric loss, okay? The value of RS is pretty small, so it is small, whereas RL has a very high value, okay? And ideally the capacitor looks like this, okay? So in this case, RL approaches to, so value of the leakage resistance RL, so RL approaches to infinity, and the series resistance RS approaches to 0, okay? So the next important point we have over here is, let's say the capacitor is supplied by a DC supply over here, okay? So as we know that I is equal to C d upon dt of your V, okay? So it means that in case of a capacitor, it means that in case of a DC supply, the voltage V is your constant, okay? So it means that dV by dt will be equal to your 0. So I will be equal to 0. So 0 amperes, okay? 0 amperes. It means that a capacitor works as a open circuit, okay? Open circuit in case of DC. Similarly, since the voltage dV by dt is equal to 0, so the voltage across a capacitor, so let's say this is the voltage with respect to time, so the voltage across the capacitor will remain same, or you can say constant, because dV by dt will be equal to your 0, okay? So it means that capacitor opposes sudden change in voltage, okay? So the reason for that is because in order to have a sudden change in the voltage, we require an infinite amount of current, okay, which is not possible. So that's all for today, guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.